Alrighty, today we'll start section 12.4, volumes of prisms and cylinders. The definition of volume is a number of cubic units that can fit inside a solid. Okay, so if I were to draw a cube, I'm basically answering the question, how many tiny little cubes can fit inside this solid? Okay, the cross section is the intersection of a solid and a plane. Okay, not necessarily an airplane, but a plane, geometric plane. Okay, if you remember that, if I cut a plane through this prism, the cross section ends up being a triangle. Okay, that's the shape that is going to form inside this prism. Okay, let's first talk about volume of cylinders. If I were to take an 8.5 by 11 piece of paper, I can roll it two ways, hot dog way or hamburger way, right? If I roll it hot dog way and get a tall cylinder with the height being 11, and then this distance being 8.5. Okay, that would be the circumference. So my height is 11 centimeters, my circumference is 8.5 centimeters. Okay, if I were to make a short cylinder, this would be 11, and my height is 8.5. So my height is 8.5 here, and my circumference is 11. Okay, do you think that these both have the same volume? Let's find out. Okay, to figure this out, we're going to have to solve for the radius. So remember, radius and circumference, to get the circumference from the radius, we know that 2 pi r is circumference, and we know this equals 11. So I'm going to solve for r. I'm going to have to divide by 2 pi. Okay, now r equals 11 over 2 pi. Okay, let's simplify that to make it about 1.75, roughly 1.75. Okay, same thing over here for the radius. I know the circumference is 8.5, so I'm going to say 2 pi r, or pi d, equals 8.5 divided by 2 pi. So now my radius is 8.5 divided by 2 pi. Okay, this calculates out to 1.35. Okay, now notice this circle is much bigger than this one. This radius is 1.75, this is 1.35. Okay, now to find the area of the base, I'm going to do pi r squared. Remember, the base is a circle. Okay, so pi times 1.75 squared is about 3.06 pi. Okay, and let's calculate that out to about 9.61. Same thing for our tall cylinder. Let's take pi, multiply by our radius, 1.35, square it, this is pi r squared. Okay, we're already at 1.82 pi, and rounded, that's roughly 5.73. Okay, obviously the area of this circle is bigger than this circle. Okay, let's talk about lateral area. Remember, lateral area is just the area around. This would be just the lateral area. Okay, would not count the two circles. So, to find lateral area, well, I just need the area of a piece of paper. Okay, that is actually going to be the same. I take the distance around it, 11 times 8.5. Okay, which is 93.5. Okay, if you'd like, you can do the same thing. 2 pi r times the height, but that's going to end up being the same thing because we know the circumference is already 11. Alright, same thing here. It's the same piece of paper, so we have 8.5 as our distance around the circle, and 11 is our height. Okay, surface area will be the exact same, 93.5. I'm sorry, lateral area will be the exact same. Surface area is a little bit different because again we found the area of our circles, but they are not the same. Okay, here we have 9.61, here we have 5.73. This circle is much smaller than this one, so obviously the surface area is going to be a little bit bigger, a bigger circle. So I'm going to take my lateral area, remember lateral area plus the two bases, and in this case the bases are pi r squared because they are circles. I'm going to take 93.5, add 2 times my area of one base to 9.61. Okay, this is about 112.72. Okay, same thing for my surface area for the tall one. I'm going to take the lateral area and add 2 of the bases, and remember bases are pi r squared. Okay, my lateral area is 93.5. Adding to 2 times the area of the base. Area of one base is 5.73. Okay, this is going to equal 104.96. Okay, so because the circles are bigger in this cylinder, my surface area is going to be a little bit bigger than this one. Okay, now for volume. For volume, the formula is just base times height. Okay, remember B stands for area of the base. Okay, so we have the same lateral area, different surface areas. What do you think about the volume? Think it'll be the same? Think it'll be different? Let's find out. Volume is base times height. Area of the base is 9.61. My height for this cylinder, is 8.5. Okay, so we get about 81.69 units cubed. Okay, remember volume has units cubed, surface area is units squared. In that case, it's centimeters. So, volume base times height for this one. I know the area of the base is 5.73, and my height is 11. Okay, this calculates out to 63.03 units cubed. Okay, this one obviously has the bigger volume. Alright, so now you have seen that. Let's practice a couple of them. Volume formulas. A prism is just base times height. You've probably learned before it's length times width times height. Well, really the base of a prism off the page is just length times width, which is the area of the base, times the height. Okay, so you could do it either way. Base times height or length times width times height. For a cylinder, it's the exact same thing, base times height. But remember what our base is for a cylinder. It's a circle. So, it's pi r squared times the height. Okay? Let's do a couple examples. Rectangular prism has a volume of 240 square inches. Okay, this should be cubic inches. This should be messed up. Two of the dimensions are 6 and 8. Find the third dimension. So I'm going to go ahead and draw a rectangular prism, but you don't have to. Okay, connect all the vertices. And then two of the dimensions are 6 and 8. Well, it doesn't really matter where the dimensions are because I have to find the other one. I know I'm going to multiply all the dimensions together, length times width times height. So I know 240 equals the three dimensions multiplied together. 6 times 8 times x. I don't know this. 6 times 8 is 48. 240 equals 48 times x. Divided by 48. 5 units. Okay? So far so good. Number 2, right hexagonal prism has an edge of 8 and a height of 5. Okay, a little bit harder to draw. Draw a hexagon. And then you're going to connect the lines straight down. And these should be about parallel to the ones that you drew above. Okay, if you want to draw the dotted lines behind it, that's fine too. So there's my right hexagonal prism. I have an edge of 8 and a height of 5. Okay, I want to find the volume of the prism. Remember, volume is base times height, or you could do length times width times height. In this case, we really can't do length times width because I don't have a rectangular prism. So this is only for rectangular prisms that will work, or square prisms. Okay, because triangular prisms won't work with that either. So I want to find a right prism with an edge of 8 and a height of 5. I'm going to have to find the area of this. So to find the area of a hexagon, remember area of a regular polygon is 1/2 A times P. Okay, so I'm going to have to draw in the apothem. Okay, and hopefully you remember what a hexagon turns out to be. This is actually a 30, 60, 90 triangle. Okay, this is 30. This is 60 down here. I know that half of 8 is 4. Okay, so across from the 60, 4 root 3. Across from the 90 is 8. Okay, my apothem is 4 root 3. So my area of the base, 1/2. The apothem is 4 root 3. And the perimeter, 6 times 8, 48. Okay, the area of the base calculates out to 96 root 3. Okay, I'm almost done. All I have to do now, I have the area of the base, 96 root 3, and I'm going to multiply that by the height, which is 5. Now I can multiply these two together. I'm not adding them, I'm multiplying them. So 96 times 5 is 480 root 3, and that's units cubed because it is volume. Okay, if you'd like to try the next one, go ahead now. Go ahead and pause it. See if you can find the volume of the treasure chest. Alright, so last one for the treasure chest. We are going to go ahead and find the volume of two distinct figures. Hopefully you saw that this is going to be volume of a prism. Okay, so volume of prism. It is rectangular, so we could do base times height, or if you want, we could do length times width times height. Okay, so it's going to be 20 times 8 times 9. Okay, that calculates out to 1,440. So that's the volume of the prism. Also, you notice that this is actually a cylinder, okay, but it's half of a cylinder. So we're going to get volume of a cylinder, and then divide that by 2. Okay, so the volume of a cylinder is again base times height. However, our base is going to be pi r squared times the height. Okay, so my cylinder is kind of like this. Okay, so this side is 8, okay, which means my radius is 4. So I'm going to say pi 4 squared, and my height is this one here, which is this one, which is 20. Okay, 20 will be the height. Okay, again, it's cut in half, because it's only the top half of the treasure chest, only what fits in there. So pi times 4 squared times 20, which is in 20 the height. So 16 times 20, 320 pi. Again, I want to divide that by 2 because it's only half the cylinder, 160 pi. So the volume of the treasure chest, well, I can't say that word, volume is 1,440 plus 160 pi.